Hi there, geometers. This is Chapter 1, Section 4, Angle Measure. And we're going to start with some vocabulary for you. First up is a ray. A ray is a part of the line. It has one endpoint and extends indefinitely in one direction. So here we have an example of a ray. When you name rays, which is probably the more important part, when you name a ray, you use the symbol for a ray, which is basically a one-sided arrow, and you always want to start with the end point. So in this particular case, we're going to name this ray, and it's going to start with the letter M because that's the end point. Over here we have the arrow indicating this is not the end point. This is the part where it's extending indefinitely. And then the second letter, because you only use two letters, but the second letter is one of the letters that the ray goes through. So this particular ray could be named MO, and the same exact ray would be MP. Those would both be the same ray, so that means that it's a ray. It starts at M and it goes through O. We never write rays this direction, backwards. So just some things to keep in mind as you're considering rays. Then the next thing is opposite rays, which would be over here. And there's two things that I want to say about opposite rays. First, opposite rays share a common endpoint, and opposite rays are collinear. Now, sometimes people think that just because two rays are collinear, that they are opposite rays. There has to be two parts to that definition. For example, we could have a ray starting at J. Let's get a different color so I can see what I'm doing here. Starting at J and going through H, so that would be at that one there. And that would be ray starting at J going through H. And then we could talk about another ray, which would start at H and kind of go through K. This would be ray starting at H, going through J, or going through K. Sometimes people think that these two rays are opposite rays because they're collinear, but these are not opposite rays, and the reason why they're not opposite rays is because they overlap. See right here where the two rays are kind of overlapping? But what's happening more importantly is the first part of the definition is that they have to share a common endpoint. The endpoint for the pink ray is J, and the endpoint for the blue ray is H, and that's not the same endpoint. So those are not, these are not opposite rays. But then what is an opposite ray? So what we want to do is for an opposite ray, then what you would have is the same endpoint. So you could say, for example, if we go back to ray JH, which by the way, JH is the only name that we can call it because it only goes through H over here. But we have some options for this guy. The opposite ray would also start with J, but this time it'd be going in the opposite direction, so it would be going through K. So JH and JK are opposite rays because they have a common endpoint, which is J, and they're going in opposite directions, and they're collinear. So that would make them opposite rays. So just wanted to make sure that you understood what opposite rays were. And then we have our next vocab, which is all about angles. And an angle is formed by two non-collinear rays. So earlier we said that opposite rays are collinear. Well, now we're looking for rays that are not collinear, but they still have a common endpoint. And here's my common endpoint, which is Y. And so there's parts to the angle that I want you to be aware of. The common endpoint, we refer to that as the vertex. And then each ray ends up being a side of the angle. So here I have ray starting at Y going through X. So that's side YX. And over here we have side YZ. And there's a couple of ways that you can name an angle. You can name an angle by the one. So we can refer to this angle as angle 1. We can also call it angle Y because that's the vertex. And then we still have two other names that we can call it. And when you call it, you can use 3 letters to name an angle. But when you do that, the vertex point should always be in the middle. So I cannot call this YXZ. That would be not okay. But I can call it XYZ. where the vertex angle is in the middle, or I could call it angle Z, Y, X, again, the Y being in the middle. So there's 4 different ways there to name that angle. When you don't have this one here, then there's 3 ways to name the angle. But if it's labeled with a number, then you can add an additional method for naming it. So you have those 4 names. Want to be also very clear, this is oftentimes a problem, and we'll talk about that in a second. Another thing that happens sometimes is there are times when it is not okay to call an angle by 1 letter. And I want to draw an example for you over here that might hopefully make sense. Something like this, okay? And I can put here A, B, C, D, and to make this easier, we're going to call this angle 1, angle 2. So basically what's happening here is if you wanted to name these angles, like if I wanted to name angle 1, it is not appropriate for me to call angle 1 angle B. I cannot use a single letter when there's more than 1 angle present at that vertex. In this case, I have angle 1 and angle 2 that are both sharing the same vertex B. That is not the case over here where you only have 1 angle coming off of that vertex. In that case, it's totally okay to call it angle Y. But in the case of having 2 angles at the same vertex, when you say angle B, it's not going to be clear to me, or anyone for that matter, which angle you're referring to. So at that point, the only way to name angle 1 would be to name it angle ABC, where B is in the middle because it's the vertex ABC, or you could name it CBA. And then likewise for angle 2, you could name it CBD, or you can name it angle DBC. Again, the vertex letter being in the middle. So just so that you're aware, it's very important that you know how to name angles correctly, using the 3 letters and also using 1 letter when it's appropriate. All right, so now we're going to talk a little bit more about interior versus exterior of angles. And so an angle, you can kind of see my plane over there, an angle divides a plane into 3 distinct parts. And so basically you have what we call the inside of the angle. This is my angle, this is like the inside of the angle, the outside of the angle, and then of course you can be on the actual angle. So we have some examples over here. Points Q, M, and N. So here's point Q, M, and N are actually on the actual angle. They're actually on the rays. Points S and R, which are over here, are on the interior of the angle. So it's important that you understand where the interior is. And then points P and O are on the exterior of the angle. And that's important when you're trying to describe where angles are and whatnot. So now we have an example. And I will tell you right now that this example is in your book. It's on page 37. And my drawing might not do it justice. So you might want to copy it from your textbook if that's easier for you. But we have all of these purple lines which are signifying rays and such. The angles are labeled with little numbers. So this angle 2 here is this angle here, angle 3 is that angle there, angle 4 is here, angle 5 is there, and so on and so forth. And anyway, they're going to ask us to answer these questions. So it says name all angles that have B as a vertex. And so here is B, and you can see we have angle 1, angle 2, and then this whole big angle. All right, so to name the angles for B, we're going to say angle 1. So let's kind of answer this question. Excuse me. Angle 1 is right here. This is the vertex B right there. I don't know if you can see it. But right there we have angle 1. And it's easier to name it angle 1 than it is to name it A, B, D, or D, B, A, which you could also do. And then we also have angle 2, which is this angle right here. And again, it's easier to name it angle 2. If you don't want to call it angle 2, you could call it DBC or CBD. But again, it's just easier, shorter, if I just call it angle 1 and angle 2. So that takes care of vertex B. Then it says name the sides of angle 3. So here's angle 3 right here. So here's one side. That's going to be ray CE. starting at C, going through E. So starting right here at C, going through E. The other one's going to start at C and go through B. So ray CD and ray CE are going to be our answers for that part. Also should say, I think I'm missing a letter, but it's okay. Okay, so then part C, I'm not missing a letter. Part C, what is another name for angle GHL? So I'm going to find, here's G, there's H, and there's L. So you can see, we can call it, instead of calling it GHL, we can call it LHG, or we can just call it angle 7. And I'm going to go with angle 7 again because it's easier, shorter to write. And then it says, you can also call it angle H, just now that I think about it, you can also call it angle H because there's no other angles labeled here. So in this case, you don't have to use the 3 letters. You could just call it H or just call it 7. And then the last one, name a point that is in the interior of DBK, angle DBK. So here's angle D, B, and K. So anything that's on this side, so here's the, again, I can write all this. There's DBK right there. So now we can, the only point that I see off to this side is E. So I don't think that you have very many options there. It would just be point E for that one. Alrighty, so that's kind of that. But now using the same map, and again, you can use the map that's in your book on page 37 if that's easier for you to see. But using the same map, you're going to have the do-it-yourself number 1, and it has 4 questions about the map. And so you'll want to use the map that's in your textbook for that. Okay, the last thing that I'm going to put on this video here is classifying angles. Classifying angles, most of you probably already know this, but we can classify angles by their measure in there's 3 different classifications. A right angle, where the angle is equal to exactly 90 degrees. And then here I have the 90-degree marker, so you kind of have an idea. An acute angle is going to be less than 90 degrees. And then an obtuse angle is going to be larger than 90 degrees, but smaller than 180. So for an obtuse angle, you want to be in between 90 and 180. If you equal 180, then you're not considered obtuse anymore, you're considered a straight angle. And we'll talk about that later. Now, I want you guys to be aware that that does not conclude this lesson, but it's the only part of the lesson that I can actually put in the video format. We will be using constructions in class, so you want to make sure that for next class period, you make sure you bring your compass and your protractor, because we will be doing some hands-on stuff with those items, teaching you how to construct angles, how to construct congruent angles, and how to construct bisectors of angles. So it's very important that you bring your compass and your protractor to class. But once you have taken all these notes down and you've done that do-it-yourself problem, then you will be done with the notes for today, and I will see you in class. Thanks for watching.